given that cosine theta equals 2/3. And theta is between 3 pi over 2 and 2 pi. They want us to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Okay, so first of all, we need to figure out what quadrant we're in. So it's between 3 pi over 2 and 2 pi. So what quadrant is that?
Oh, quadrant 3, right? Or 4?
Quadrant 4.
4, yeah.
There has to be one. 4 if it has 2 pi, right? Isn't that what you-
Yeah, 2 pi is 0, like, because it's 0 place. So we're in quadrant 4. We're going to use our identities. So our sine half identity is sine theta over 2 equals positive and negative square root of 1 minus cosine theta over 2. All right, well, they gave us cosine theta. So I just have to plug in and simplify. And then the reason that I need to know what quadrant I'm in is because it has a plus and a minus. I really only have one answer based on what quadrant I'm in. So I'm just plugging in 1 minus 2/3 over 2. And you can simplify that whatever way you want. I'm going to multiply just because. I'm going to distribute a 3 on top to clear the fraction. If you multiply the top by 3, you got to multiply the bottom by 3. So that would be square root 3 minus 2 over 6, which simplifies to 1 over square root 6, which then I have to rationalize. So I get square root 6 over 6 for sine. For cosine, the cosine identity is 1 plus cosine theta divided by 2. You're just plugging in. So 1 plus 2/3. Again, I'm going to multiply by 3 to clear the fraction. So I get square root of 5 over square root 6. You still have to rationalize. Multiply both the top and the bottom by square root 6. And you get square root 30 over 6. Are y'all okay? Before I go to tangent, anybody have a question?
On the last one, the square root was over the whole problem. Why did you only put the square root on the bottom, and then this one, we'll have it keep on.
Okay, because this square root 5 over square root 6, square root 5 over like that That is the
Because
exact
mine's
same.
technically a perfect square.
It's the same thing as this, square root 5 over square root 6. So in my head, I just was like, well, that's a square root 6, so I can multiply both the top and the bottom by square root 6. And then a square root times a square root cancels the square root, and now it's just a 6.
On the, not
But the-
Oh, you mean up here?
Is it, was the 1 not have the square root because it was a perfect square?
Yeah, because square root of 1 is 1, so I just did it. I just skipped that step.
And then she put it where, just write the
Oh,
square root sign of the or. Or on both of them. Instead of just putting one through one.
So, are y'all good now? So now we're going to go to tangent, and tangent has 3 to choose from. Really doesn't make any difference which one you want to choose. Ooh, even better, y'all. I have a better idea. Let's just do, if we want to do tangent of this, that would be the same thing as tangent is sine over cosine, and I already found those. Right?
yeah.
So that might be easier than either identity. It might be, might not be, but I think it is. So I'm going to use that. So since I already found that sine of theta over 2 is square root 6 over 6, then I can write that as square root 6 over 6. Cosine is square root 30 over 6. So then you just keep, switch, flip. Keep, switch, flip. Those cancel. And I get square root 6 over square root 30, which I have to rationalize. So that's square root 180 over 30. 180 does simplify. Let's see.
30 and 2? No.
Let's see.
I have a calculator.
No, I
2
feel like
and
Yeah,
90,
30 and 2.
9 and 10, 3 and 3, 2 and 5. 6 square root 5.
Oh, so I have a calculator, so I'm not doing that.
6 square root 5 over 30. And then the 6's would simplify, so it'd be square root 5 over 5. I don't know if that was any easier or not, but it wasn't bad. Okay, so now the only other thing we have to do is we have to remember that we're in quadrant 4.
So which one?
So what is positive in quadrant 4? Because everything else is going to be negative.
Cosine.
Cosine is positive, which means
Oh, you're
everything.
asking for
Yeah, no, you're
Okay.
right. So we're in quadrant 4. Cosine is positive in quadrant 4. Everything else should be negative. So my sine value up here should be negative. It should be negative square root 6 over 6. And my tangent value should be negative. Negative square root 5 over 5.
Would that change the answer at all if you did, if those are supposed to be, or since sine?
It would have if I had made sine negative to begin with, it would have given me a negative for tangent when I did it.
Okay.
So I just always check at the end. It just makes it. That way, even if I mess my sign up somewhere, just check that part. Okay. I think this is the last one.
Yeah.
in this part.
Oh no, there's 2 more.
In this part or
It would be.
For this whole section.
I'll tell you we're going quick.
Dude, yeah, we're flying, just like this. And then we're going, no, we're just here, or we're.
Yeah.
So we're just gonna, like.
It's 2 separate designs though.
No, let's just have it set up how long it is. And then how many questions. Well, the first one's our key. You know, this.
I know.
That's what I
I haven't even started some. Okay.
Yeah.
Did y'all do the 18 question one?
That one's after 7.
That's the one that we learned yesterday.
Yeah, so that's like do 7. Can I
Yep.
use it with the student?
Wait, is this one gonna be due on Sunday or are they both gonna be due on Saturday?
Were they both set to be due on Saturday?
I think
Yeah.
Because I was going to do them all in one day and then I didn't. Is that why?
Yeah.
Okay. Yeah, no, I'll fix it. Remind me when I finish this to fix it though, 'cause I'll
How
forget.
many more notes are we going to take for this section?
For this section today,
No, for like.
for chapter 7.
There's a lot.
Yeah, it's long.
Does that say 12x?
You know how we're usually like 0.6 and then
I think this one, this one, does that say 12x?
Yes. Yeah, this one has 7. Okay, so bless you. So they want us to simplify this. So if you see that, what does it look like? Mm-hmm.
Yeah.
Which
Yeah,
one?
that.
Which one?
I'm going. The sign.
Sine is
Cosine.
Yeah, so this is cosine. So the cosine half angle identity looks like this. Cosine half angle equals positive and negative square root 1 plus cosine theta over 2. So if that's the case, then this piece, right, is like theta. Which means that all of this actually just equals cosine 12x divided by 2, which you can simplify to cosine 6x.
I have a feeling that
That
maybe
is
the
it.
test, you did that wrong, and that was so simple.
Wow. I don't know.
Sometimes the simple ones are like, those are the ones that you're like, that can't be it, so you keep trying to do stuff. Yeah.
Because, like,
Wow.
I don't know, I just don't think simple questions.
I know. I'm with you. I understand.
Well, because it seems too simple.
Exactly. Better I just start recognizing that I just write something.
No, you see why I just got confused on that last one? Because on the other ones, when we put it into the equation, it was the one that was 2 times what theta was this time.
It's-
But I know.
Yeah, yeah. But if they don't tell you which thing you're, so just like the one we did a minute ago where it was cosine 15, you could do that by cosine difference identity.
Yeah.
They specifically told us to use half angle, but you could do it both ways. You get the same answer in the end. Okay, so which one does this look like?
I mean, 5 fish.
Yeah, that's alpha.
Oh.
It's lowercase alpha.
It looks like the tangent.
The third chance.
Yeah, so it's the tangent one. So tangent of theta divided by 2. The third tangent one is 1 minus cosine theta over sine theta. So that means this piece is theta. So this is tangent tangent 5 alpha divided by 2.
It's not as bad as drawing a deep sine.
And you just leave it like that because that doesn't simplify. I mean, it's a
Does
It's a
it
fish.
just go under the 5?
yes. So remember when you put tangent in your calculator, it pulls up. So this is tangent theta over 2. So it's the angle that comes after the word. All right. So y'all good? That's that.
Somehow.
Okay.
Good with alpha, yeah, that's
I
just simple.
like this.
Yeah. Pretty easy.
It's an easy section.
All right. Last thing. My favorite.
Possibly my least favorite this semester.
What, the
It's
6?
trade. Yeah, it's definitely this semester.
I don't know,
Chapter
it's like
6.
this hard and saying bearings
What was chapter 6?
She's crazy. Favorite.
Don't
Her
worry.
favorite.
Does that alpha next to the tangent 5 over 2?
Yes. That pen's not very good. I will.
Oh, I just put it as once.
I'm gonna start drawing that at sine.
Wait, you like bearings?
This is hard.
It's all good.
No.
She probably likes rational expressions too.
Could you imagine if like someone took this class while taking the second math? Like some of those two persons often.
That would not be smart.
That would be
I would hope they wouldn't let you do that. So I hope somebody very wise would go, no. Okay, so remember when we're verifying, we prefer to start on the more difficult side.
Oh, yeah.
So, which of the two sides looks more difficult?
One that's
So-
weird.
Yeah, the one that's square is definitely more difficult. Okay, so when you're verifying identities and you have something that's squared, you need to go ahead and square it. So, just a second, I'm going to come over here and I'm going to write this differently because I just don't want to deal with the fractions for a second. So y'all good? If instead of sine theta over 2, I just do sine, let me get a good letter, sine p plus cosine p squared. It's the same thing. I can go back in and put theta over 2. I just don't want to deal with the denominators for a second. Okay, so I'm going to square that. Squaring something means what?
Multiplying it by itself.
Multiplying it by itself. So I'm going to write it down twice. So sine p plus cosine p times sine p plus cosine p. All right, so now I'm just distributing, because that's how you do this. That's how you square stuff. So sine p times sine p, sine squared p. Sine p times cosine p is just sine p cosine p. Cosine p times sine p is also sine p cosine p.
Do we have to have it twice or do we just put two?
You can put 2 if you want to, but I'm going to do that in just a second. And then cosine p times cosine p is cosine p squared. I should put the square. Sorry, I know. I should put the square between the cosine and p. So excuse me for making a mistake. Okay. So now I'm going to go ahead and just combine like terms. There's 2 of those. So this is now sine squared p plus 2 sine p cosine p plus cosine squared p. Are y'all okay so far? Okay, now even before I go back and put in my half pi, anytime you have these 2 things, it should remind you of your favorite identity, which is sine squared theta plus cosine squared theta equals 1. So I have sine squared p plus cosine squared p. So take them out and just put a 1. So 1 plus 2 sine p cosine p. Okay, so are we good that far? Okay, so now I am gonna put back my half pieces. So I'm gonna come back to over here. All of that jazz I did, I now have 1 plus 2 sine theta over 2 cosine theta over 2. Well, now those of you who weren't here yesterday, you won't recognize this because you don't have this identity, but that is one of our identities from yesterday. 2 sine theta cosine theta.
Wait, so cosine theta over 2, or is it
It's
just?
just, it should just be under the theta. I don't know.
Okay.
I was like,
I just was getting excited and getting ahead of myself. So excited about what comes next. Okay, so do you have your identities from yesterday?
sine 2a equals 2 sine.
Sine 2a. So the identity that we learned yesterday looks like this. Sine of 2a equals 2 sine a cosine a.
Oh yeah.
So that's this right here. So that means I can replace this with sine 2. So 1 plus sine 2 theta over 2. And then what happens to the 2 and the 2?
They cancel.
So you get 1 plus sine theta, which is what this is. So you did it. You verified. That wasn't so bad, right?
That was
I mean,
triggering.
I can understand how this is your favorite because you just know all the identities and you know how to use them. But not knowing the identities
Right.
really hurts.
Okay, which it does.
Only strap.
It absolutely does. And the only way that you start to know them is to, number 1, have them all right in front of you. And number 2, you have to do them. You just have to keep doing them and go, wait a minute, that looks kind of familiar until you get used to it. Let's do one more of these of verifying.
I kind of liked that one.
It was fun, wasn't it?
I kind of actually understand chapter.
Let me find out one.
Yeah, that one was my moment of realization. I could, because like yesterday I was kind of just like completely lost. But I understand.
This really made sense to me until we got like to the very last 2 and I was like,
I'm trying to figure out one that.
let's see, they're so long.
I'm just gonna.
I
Whenever
wonder
I
how long that had us do one problem where we did the one that takes forever that we don't do the first one. And we didn't even make it all the way through. And it was like more than half my page. You're like, we're gonna stop.
I remember the one matrix that we had.
Oh, that's Gaussian elimination. I like that too. I think that's fun too. They really are puzzles. That really is like a legit puzzle.
No, I remember the MyLab version of that, and we had like 1,000 stuff.
I was like,
I probably didn't do that one.
And I messed up on 1+.
I loved that assignment. I liked the matrix.
Okay, so we're verifying this identity. It's very clear which side you should start on with this one.
Oh, that's easy.
I think it should be the right
This
side.
one's easy. If you just find these. Pretty good.
Okay, so
Lyndon, you think we
Wait a
should be
minute.
on the right?
No.
what do you think? What should we do?
Wait, is that a list?
There are so many different ways that you could do this. So
Oh, wait, isn't that tangent?
No.
That
It's
hand?
backwards from tangent.
no, it's very close, but it's not.
Yeah, it's
I thought it was that one. I was
version.
like, oh, just
Yeah.
learned this.
Now-
Easy.
Ooh.
Now, let me say this. If I factored out a -1 across the top,
The way you just use it.
you could.
And then the opposite of tangent, cosine next one is just.
But the problem is it would be tangent of half. Oh, that'd still work, I think. Maybe we should do that. That's one way to do it. We could also, those are both double angles, so I could use the cosine now there's 3 different cosine double angle identities. I could change that cosine double angle somehow, and I could change the sine double angle also. I think either way's faster, but either way.
Is double angle just where it's like over each other, or what is double angle?
Double angles are the ones we did, there's just 3, it's 3 identities, one for sine, cosine, and tangent, but cosine happens to have 3. So it's 5 different identities that we got yesterday.
It's all in twos, actually.
Yeah.
It's all
Double
in
angle means 2 times the angle. 2 times
Okay.
theta or 2 times x.
Okay.
So this is 2 times
Twos
x.
is-
So I could use those, or I could make this look like tangent. What do y'all want to do? You tell me.
I think we should put a negative in it and make it the tangent.
Okay. So I'm going to do that. That means on the top, I'm going to factor out an... Wait, will that work? Hold on, let me think. If I factor out a negative... No, it won't work.
Because then there's -1.
Yeah, because that would make it -1 minus cosine squared. Dang it, that won't work.
I really thought I had something else.
So we'll use our cosine double angle identities. Somebody give me which one you want to use, it doesn't matter. For cosine 2x, which one?
double angle one?
Yeah, which one of it? Because there's 3 of them. So you just give me one.
Let's do the 1 minus 2 sine squared x.
Oh, I found
Okay, so I'm going to put it in parentheses. 1 minus 2 sine squared x. All right? And then on the bottom, I've got a sine only has 1. So I'm going to change my sine to 2 sine x cosine x, because that's the identity. Oh, this is actually easy. Okay, so 1 plus 1, that's 2, minus 2 sine squared x over 2 sine x cosine x. All right, now looking at the top. Now, I know throwing the word sine in there makes it, like, for whatever reason that confuses people. But imagine that you were just looking at something that looked like this. Let's say you had 2 minus 2w over 2wy. And I wanted, what would I want to do? What would you want to do there? If the goal is to simplify.
Get rid of the W.
For sure I would want to cancel out the w. Can you?
No, because it's
No.
No, because I have this. But what else what else would I want to cancel?
The 2.
The 2's, right? Can't you cancel the 2's?
Yeah.
Now, I can, but really, could we just divide them all by 2? Yes. Technically, you really need to factor it out, right? Factor the 2 out. And if I did that, that would be 2, 1 minus w, right? And 2, wy. And then I can cancel my 2's. Yes?
Yeah.
That's all this is. I got all these 2's. So I'm going to factor out a 2 on top. And that makes it 1 minus sine squared x sine x cosine x. What happens to your 2's? Now they get to cancel. Now, anytime you see a trig value squared and a 1, it's one of your Pythagorean identities. Yes, the top is going to be cosine squared x. Because it is this identity rearranged. They just moved the sign to the other side. And that's where you get minus sine squared.
I should cancel out 1 number.
Yep. So just to make sure everybody's clear and not to assume, cosine squared is the same thing as cosine x, which means,
Oh, you can cancel it.
yeah,
This is so easy.
which means that you just cancel a cosine, and cosine x over sine x is cotangent x, which is what we were supposed to get.
Hey-o.
Yay! That wasn't hard.
I'm just gonna,
Yay!
Kind of fun,
if
right?
it gives me cotangent x again, I'm just gonna write cosine x over sine x again.
Look,
This is the only time I've liked this class since first semester.
I feel like when it's like that little endorphin hit when you get it and you're like, oh my gosh, I got it! It's like, it's cool.
It's
Nobody's
great.
doing-
Except now I have to do assignments over here instead of.
You'll have plenty to do, right? They'll make you do these. They're so fun. Okay, I won't make you do them.
Yay.
Can we get the,
The other identities, yeah. Here. Maybe we should put them all together.
Today.
Yeah, we can. Anytime. So, get a plain piece of paper, maybe one that, you know what? I might have cardstock. You could write
Oh,
on.
that'd be great.
And then you can find it. And then I might even have
Do you have
protectors.
the paper notes from yesterday?
I do. It doesn't have lines on it, so if you need lines.
Yeah, I don't want to watch the video.
But will you know what you're doing? If you just copy the notes?
you say it's
Maybe
similar to this, right?
It's very similar.
Oh,
It's
so
just three
maybe-
different identities.
Yeah.
Probably, yeah.
It was very understandable.
Thanks.
I mean, like, still,
I would be all for
you're saying
this.
the same thing in this class.
I've done assignments.
Because we're gonna put all the identities on it, and then that way it's easier for you to find
any
it.
video, I just did the assignment and you like help us all this on it.
Mari, what book are you reading?
Okay. So,
Oh my gosh, on one of the sections I wasn't understanding at all. I actually went and read the textbook. And then I was
The one time the
oh my gosh,
textbook actually made
using my
sense.
sources.
Yeah,
imagine that.
I forgot we
Literally
actually
the one
have
that I paid for.
That's what, like, a lot of times when people are like, I don't understand anything, and they come, the first thing I say, well, did you watch the video? No. Well, I mean, what did you expect it to just magically make sense? Like, oh, that makes sense. That's fine.
supposed to work.
Okay, so these are the first are the fundamental identities. These are the basic ones. These are the ones you will have to have memorized for sure. I know you
Oh, there's
will.
no line.
But still, until you have them memorized, you want to have easy access to them.
So is this like a cheat sheet?
This is like if you have it in front of you while you're working your problems, it'll help.
Oh, so no,
So we're not allowed to have this
On the test, no.
But
That doesn't help.
Oh, there's my completely straight line that I can't draw.
Yeah, I'm not even gonna try to make straight lines.
Oh, it's,
I'm gonna write all
Let alone keep my letters straight.
I struggle with it so much.
so the first set are the reciprocal identities. The next set is the quotient identities. Then the Pythagorean identities.
Are those all twos or threes?
Twos. These are your cofunction identities. Okay, my guess is that that is all of the ones that you have to have memorized. All of the rest of them that I give to you, they're going to give to you.
Are you good at guessing? That's the cool question.
Okay, so sorry.
I was about to say, I'm like, I just finished what is that called? Forgot it.
That's a good question.
Cosine, yeah. Cos. C-O-S.
Of course, the easiest ones to remember aren't on there. But the good ones.
Any more identities after today's lesson?
I think this is it. There's no more identities. I think we've done them all.
Would you just like learn new ways to apply them for the next research?
Mm-hmm.
My plus sign looks like I've learned two things. Can I see that for you? Can I see that for you?
Okay. Oh, I have no space for that.
You say you don't have room?
Yeah.
There's a bag.
Oh yeah, there's a bag. It
Look
looks
at it all
better if
the
I
way down,
put
don't
it
worry
all
about
on
the
one
front.
page though.
Why so small?
They're having one of them.
I struggle with making big square root cells for some reason.
Just really simple. I just made them too long.
I just do the top part, say, yeah, it's close enough.
I just struggle making them down and up. Like my brain just doesn't like it.
Mine doesn't like this, and I go too far.
That or
Mine like turns into a curl too long.
that or mine just ends up just going up or something. I don't know. My brain just doesn't work.
Okay. That's it. That's all I got. And I will change the due date on this part, this one.